Hey everyone, I'm Jamie, and welcome back to Built from Scratch, where we're building a 2D game engine from the ground up, piece by piece, with zero perfectionism and zero gatekeeping. If you've ever looked at a finished game engine and thought, there's no way I could build something like that, you're exactly who this series is for. Let's build it together, step by step.
Spreading knowledge, one byte at a time.
Last time we laid down the renderer, that part of our stack that turns raw data into visual pixels. Just enough to draw a rectangle, nothing fancy, but it worked. And it gave us a clear boundary to build from. Now we're pivoting to the beating heart of it all, the core engine logic. But let's zoom out for a second. What is a game engine really? It's not the UI, it's not the art, it's not the ECS or even the renderer. At its core, a game engine is a loop. One that ticks at a steady pace, updates the simulation and tells the renderer when to draw. That's it. It's a clock with responsibilities. It tells your logic update based on the time passed. It tells the renderer draw what needs to be shown. And it does that hundreds of times a second without skipping a beat. But timing is everything. If your update loop runs too fast or too slow, your game feels off. If your renderer isn't locked to a frame rate, animations stutter. If your physics runs based on frame time, chaos. That's why we're writing our own update loop and render loop, independent of each other, both locked at a fixed rate. This gives us predictable physics, stable visuals, and a clean mental model of how the whole thing ticks. So in this episode, we're building the engine brain. It won't care what's being drawn, it won't know what game it's running, it just runs the loop on time, every time. But here's where things get even cooler. We're also introducing our core package, and this is more than just bundling stuff together. It's a master kit, a package that brings together all the essential pieces. The engine, the renderer, the ECS, eventually inputs, audio, scenes, the works. But each of those tools still lives in its own package. So if someone just wants to use the renderer, they can. They can install @GES/renderer and they're good to go. If we build an input manager that could work in a browser app or even a UI tool, it could live on its own, versioned, testable, and portable. But when it's game time and we want everything wired together in one clean dependency, you just install @GES/core. It's like getting the whole toolbox pre-assembled without giving up the ability to grab just the wrench if that's all you need. That means our editor only needs to depend on one thing, core. No long import chains, no managing a dozen versions, just one sharp modular tool built from battle-tested pieces. It's a clean way to scale, and it keeps us flexible for whatever we build next. Now, with our foundation laid and our design locked in, let's jump into wiring up the engine tool itself. All right, so we're back in the project here. We've got it still running fine. So we're going to start by creating that core package. So I'm just going to add core. And then we're actually going to give these a namespace here, like that. So I can come into the renderer. We go to the package.json, we can rename it @GES/renderer. And then from there, we can copy the renderer package and we'll have a core package. So let's rename this to core. Come into core, we'll go to packages. We're going to add a dependency and it will be @GES/renderer. And that'll be a package workspace. So we'll have our first dependency there. Then we can come into the core index, get rid of it. We'll just say export asterisk from types. And then we'll also create a new file called renderer. Let's actually call it renderer lowercase .ts. And then that will export asterisk from @GES/renderer. So, and then in the index, we'll say export asterisk from @GES/renderer. So they both will export from that, but we can actually just get the render package if we don't need any of the other things in a specific file. So that's good there. Now we'll come into the client. We'll go to the package.json. We're going to update the dependencies. So instead of renderer here, we're going to say @GES/core. And then in that component, the editor here, we can come up where we're getting it from renderer. From now on, we'll grab it from gs/core, and then we can say /renderer. So we're going to get errors. We don't have this package. It doesn't exist inside of there yet because we haven't installed it. But we did change it. So we could say uninstall here. So at gs/renderer, let's see, workspace name already exists. Let's see, we'll go into packages, gs/renderer, that's fine. Go into the gs/renderer. Let's go back into core, package.json. So one thing that I didn't do yet, which I wanted to do already, we'll say exports. And in here we'll say dot, which means the root package we'll have a types, and that will be in the dist folder, just like up at the top here, dist/index.d.ts. And then we'll also have import, and that will be dist/index.js. And then we can do the same thing for renderer. And then this will have types, dist/renderer.d.ts, and types, import dist/renderer.ts or .js. So let's see, run build, and we didn't rename it. We have to be in our core. We have to actually have it named core. There we go. That was a silly mistake there. Let's see. All right, bun install, bun build. We're just going to make sure things build. Should be good. Let's see, core. Let's restart the TypeScript server here. And then let's say renderer here. Let's see. Oh, and we need to get rid of this. There we go. That was what the problem is. We can keep this at gs/renderer. So, all right, let's see, bun install, make sure that works, and bun run build. Everything should be updated after this, and we could start working on the engine package. Bun dev. There we go. We're back to where we were, but we have a core package now. So now what we can do, we'll do the same thing. We'll copy the renderer package, paste it in here, and we'll rename it to engine. Then we'll come into engine, package, engine. That's good. Go into the source, types, get rid of that, and get rid of this. We'll export asterisk from types, and we'll do a few things in here. So we will be defining in the types two types. So we'll have a update function that the user of the engine will define. Update will take a delta time, and then void. So we're looking for a function that accepts delta as a number and doesn't return anything. Same exact type of thing for render, but we don't accept any values. It's just going to be void. And that's one of the things that our engine is going to take into it. So right here, we can import type update function and render function from types. And then we can also define, let's actually go back into types, and we'll define an interface. And these will be engine props. So we'll have that update, which is an update function. We'll have which is a render function. Then we'll also allow them to set a desired tick rate as a number and desired frame rate as a number. So this will be what gets passed into the constructor of our engine. So we can come here and add engine props, and we will now export class engine. So we can start working on the actual class. So we'll have some things set privately. So we're going to have quite a bit of private variables for this. Stop is equal to true. We'll have a last time. We'll have a delta. We could call it update DT or update delta. And we'll also have a frame or render dt for render delta, and these will be used internally. So then we can also have a private frame rate, a private tick rate. We'll have private ticks. So we're just creating these and assigning them values to start. And so we have ticks. Let's say private renders. We'll have our update function, which is an update fn, and private render, which is a render fn or render function. We can set these to start, so that just kind of makes sure they're set to something. And then we're going to have that desired tick rate number is equal to, and let's put the desired tick rate to 240. Then we'll do the same thing for desired frame rate. We can just set that to 60. We'll have that constructor. We'll take update render desired tick rate, and this is of type engine props. So now inside of our constructor, we'll have this dot update is equal to update because it must be passed in. This dot render is equal to render, but we have some optional ones. So we'll say this dot desired tick rate. We'll say frame rate first. Frame rate is equal to desired frame rate, and then this dot is equal to desired tick rate. So this dot, let's see, frame time step, frame rate, tick rate, ticks, renders. We're going to have, I forgot, two more private update time step, render time step. So then in here we can say this dot update time step is equal to 1000 divided by this dot desired tick rate, and then this dot render time step is equal to 1000 divided by this dot desired frame rate. That should be good there. So this is just going to set up our variables that we need within the actual loops themselves. So we'll create our first one, which is the update loop. And in here, we'll check if this dot stopped, then we just return. We're not doing anything. We just return out of the function. All right. And if we aren't stopped, then we'll set const now equal to performance dot now, which we want to make sure that render delta, let's see, last time. We may need a private render last time. Let's keep that. And then we'll call this update last time. And we'll use these both. And then since we can actually just set these both to performance.now, do that for both of them. That way the last time will get set correctly when we create this. So now is equal to that, const frame time or tick time now minus this dot update last time. This dot update last time is equal to now. This dot dt or update dt is equal to tick time, and actually it's going to be plus equal. We're going to increment this value, and you'll see why right now. So we're going to have a while loop, and we'll say while this dot update dt is greater than or equal to this dot update, I think, what do we call it? Tick. Let's see. It should be steps. Update time step. And then we do want another variable. We can put this up at the top as well. And we'll call this private EPS or epsilon, which is just a number that's going to be used 0.00001, we'll say. This is just a number that helps with CPU drift. 3.0 times 9, and then 9, and then that divided by 3 doesn't really necessarily get you back to 3. It could give you 2.999999. It's just a weird CPU quirk. So epsilon is just a value that we use to help with that drift. Yes. So this dot update time step divided by 1000. There we go. That's going to pass in the delta time Then this dot update dt minus equals this dot update time step. All right, so minus equals time step, and then this rate is equal to this dot tick rate times 0.9 plus this dot update time step times 0.1. So then we just increase ticks. So basically this is a loop that's going to check if the delta time is greater than the update time step. So essentially we're going to run a while loop that decreases the delta time until we're back where we're supposed to be. And then each time it does that, it runs the update method that we pass in, giving it the delta time. And this tick rate calculation is going to give us our actual tick rate, but it's going to be an eased value. That's all this does, easing. So this will run and it will keep the update running at a set amount. And we're going to essentially do the same thing in our render. We will have a this dot update int val, set that equal to set timeout this dot update loop. So we're going to create this value here. This will be a private function or private method or variable. Private is a number, and then we'll have private render int val as a number. So these are going to be set timeouts, but we'll change these. Actually, you know what? We aren't going to have a interval for that. This one will be different. That's why I did it that way. So this will be our render loop. And right after this, we'll say request animation frame, passing in this dot render loop. All right, so these will be the same tick rate. We'll call this render. Oops, make sure we don't update the wrong thing. We just want these two here. That's good. So we have render time. This will be render last time, and then render dt, render time step. Is it frame rate? And then renders here. So basically they're going to do the same exact thing, and then this is going to call render without anything. So this dot render loop, this should do the same thing but for the renders, and it will keep our frame rate consistent here. So that should be good. Then we can have a start. So public start. Now these are both private here because we aren't going to, no one will call those specifically. So start is going to first check if stopped return. So if this dot stopped is not true, then we just return. This dot stopped is equal to false. This dot update last time is equal to performance dot now. Same thing for this dot render last time. We could probably even go as far as saying this. So then we set those both at once. This dot update dt is equal to 0. Dot render dt is equal to 0. This dot update loop and this dot render loop. So we call both of those, and then we'll have its counterpart, which will be a public stop, which just says this dot stopped is equal to true, and then clear timeout this dot update int val. Perfect. So then we can have some nice functions that help. So we can say public get tick rate. We return 1000 divided by this dot tick rate plus this dot EPS. And then get frame rate, which will be a public, return 1000 divided by this dot frame rate plus this dot EPS. All right, so this should be the core of the engine. So should be good. Render last time. Yep. I did forget this needs to be render last time. There we go. We need to make sure we we have that set. So now we should be able to add this to our core package. So we'll come into core, go to package.json. We'll come to our dependencies, add at GES/engine workspace. So make sure that we've named it inside of the engine. Make sure that it is at GES/engine. And then in core, we have that. We also need to do the same thing that we did here. Copy, paste, and this will be engine. So then we can come into source. We'll have a engine file that will do the same thing. And engine here, bun run build. I think we need to run it. Bun run install. We do need to come out to our tsconfig here. Let's add the core or the engine. We're running install. We'll restart the TypeScript server. And for sanity, run bun dev. All right, cool. So now we can come up into our client, into the components, the core, this here. We can add our engine now. So we'll import engine and type engine props. And actually we'll import engine like so from gs/core/engine. And then we can do import type update function, render function, and engine props from gs/core/engine. Then one thing that I could do is we could try to track the FPS now too. So we'll say const FPS and set FPS is equal to use state, and we'll set this up as a string or undefined here. So we'll do this a bit differently here. This should be fine. We'll let x equal 20 can come up here. Then we'll create update function, and it's going to take delta time as a number. And then this is just going to say x equals x plus 20 times dt. And we'll do the same thing, percent r.width minus 80. So now we don't do that there. We can copy this, and then const render is a render function. We want to do the drawing. And after we create the renderer, we can create the engine, and that's going to take, we'll say engine props is equal to, which is engine props. We have a render desired frame rate, which we can set to 60, and desired tick rate 240. Then we should be able to just pass that in. Then we don't need this anymore. It means we don't need to clear that. And we can say e.start. All right. So now if we look, we're going much slower, because now in our update, we're taking into consideration delta time. So when we say x plus 20 times delta, we're basically saying 20 pixels per second. So now that rate can go up if we wanted to. We could say let speed equal 5 pixels. We could say 50 pixels per second. Then we got a little bit more speed. So up here, FPS, let's go down into the return here. We'll say div class name equals absolute, top 0, left 0, padding 4, and then text white. And inside of this, we'll have an h1, class name equals font bold, and we can put frame, we'll say FPS, and then we can put FPS in here. And then every time we render, let's say, we can just say set FPS equal to e.get frame rate. Oh wait, we want to say .to fixed. The reason why I set it as a string is because we want to get just 2 positions past the decimal. So as you can see, we're getting 60 FPS right now. And we can change that, and it'll update to the desired amount that we want. Obviously, this is all just to get stuff going. So eventually we're going to go in and we're going to optimize things, and we're going to make better functions. But this is just setting everything up to be used in a modular and expandable way. So that's where I wanted to be for now. We'll go into the future, we'll update and make better rendering, we'll do better engine logic, we'll be able to update everything as we go. Alright, so to recap, we just built out our core and engine packages and wired them straight into the client editor. Now, instead of every module needing to know who's doing what, our core package becomes the single source of truth. The one import that ties the engine, renderer, and any future systems together. We designed it this way so everything stays modular and publishable. Each package, engine, renderer, core, can live on their own, or work together inside the editor without a bunch of spaghetti dependencies. The engine we wrote gives our project a heartbeat. Consistent tick and render loops that keep time and pace across everything we'll build next. It's lightweight, expandable, and now fully integrated into the editor UI. So we officially moved from drawing frames to running frames. The architecture is clean, the update loop is solid, and the editor is now powered by a real engine that will drive the rest of this series. Next episode, we'll take this heartbeat and start connecting it to actual systems like scene management, entities, and component logic, and we'll watch our framework start to become alive. As always, if you're following along, like, share, and drop a comment with ideas or improvements. This project is built from scratch and built to grow with you. See you next time.